Here we are in the second video for section 1.5, and we are ready for example number 9. Now 9, 10, 11, and 12 ask us to find the real solutions of the equation, and what we need to realize is that these problems are all in quadratic form, which means the first term is going to be something squared. The middle term will be whatever that variable is alone, and then the last one is a constant, but it's going to look strange. And so we begin with this first problem. Now this is in quadratic, and how I know it's in quadratic is I simply look at this one right here. I have x to the 6th. Is this half of it? X to the 6th, half of 6 is 3. And then does this have no variable at all? It is in quadratic form, which means the only thing is when we try to factor this, and factoring is probably the most useful way to do this, instead of just having x, in this case we're going to have x to the 3rd, because that is what is going on right here. So I can factor this as x to the 3rd minus 27 and x to the 3rd plus 1. And then I can treat each one of these as separate problems. So then I get x cubed minus 27 equals 0. So that means x cubed equals 27, or x equals the cubed root of 27, which is 3. It's not plus or minus because cubed roots don't work quite the same way as square roots. And then likewise, x cubed plus 1 equals 0. X cubed equals negative 1, so x would equal the cubed root of negative 1, which equals negative 1. Number 10 is very similar. X plus square root of x equals 6. First thing, I need to get everything to one side and set it equal to 0. So I get x plus the square root of x minus 6 equals 0. Now I look at this. This has an exponent of 1. If I would rewrite this using an exponent, this is x to the 1/2. So this has a power 1/2 of this. This is in quadratic form. That means when I factor this, instead of having just x, I will have square root of x. So I get the square root of x plus 3 times the square root of x minus 2 equals 0. And then I can set each one of these equal to 0 and go from there. Square root of x plus 3 equals 0. Square root of x minus 2 equals 0. Subtracting 3 from both sides, we get square root of x equals negative 3. And squaring both sides, so x would equal 9. But here we look. What's the square root of 9? It's positive 3. So we have to eliminate that. Another way to look at it is in the original. Does 9 plus 3 equal 6? No. So we have to eliminate it. Here, we add 2 to both sides and square it. X equals 4. Going back to check. 4 plus square root of 4, which is 2. 4 plus 2 equals 6. So that one's good. So this is where if you don't check, you will get it wrong. And so you do need to make absolutely sure that you check in each one of these situations. Example 11. 1 over x minus 2, the quantity squared, minus 2 over x minus 2 equals 3. Let's get rid of the fractions. And the least common denominator is x minus 2, the quantity squared. So this will become 1 minus, okay, now I need to multiply this by x minus 2. And I need to multiply this by x minus 2, the quantity squared. So this becomes 1 minus 2x plus 4 equals 3 times, foiling this out, x squared minus 4x plus 4. Combine like terms and distributing. To 3x squared minus 12x plus 12, and then adding 2x to both sides and subtracting 5, I get 3x squared minus 10x plus 7 equals 0. And then this will factor to 3x minus 7 times x minus 1, and setting each one equal to 0, 3x minus 7 equals 0, so 3x equals 7, x equals 7/3, or x minus 1 equals 0, x equals 1. Now quickly checking here, if you do 1, let's take the easy one. 1 would be 1 over 1 is 1, minus 2 over negative 1 is negative 2. 1 minus a negative 2 is 3. So 1 works. 7/3, this would be 1/3 squared is 1/9, so this becomes 9, minus this would be 1/3, 6, 9 minus 6 is 3. So 7/3 works as well. Now we get example number 12. X to the 2/3 minus 3x to the 1/3 minus 10 equals 0. Now this is pretty simple to see that it's in quadratic form. We've got 2/3, half of that would be 1/3, so that means as we factor it, it's going to be x to the 1/3. So x to the 1/3 minus 5 times x to the 1/3 plus 2 equals 0. So this becomes x to the 1/3 minus 5 equals 0. X to the 1/3 equals 5, and to get rid of the 1/3 power, we cube both sides, so x would equal 125. Likewise, x to the 1/3 plus 2 might equal 0. X to the 1/3 would equal negative 2, and cubing both sides, x equals negative 8. And doing a pretty quick check, you will see that both values do work. 13 through 16 deal with absolute value. And when you deal with absolute value, as soon as you get the absolute value on one side and whatever on the other side, then you immediately split them up into two different equations and solve each one individually. So, for example, if we begin with example number 13, the absolute value of x minus 3 equals 0. Now we have the absolute value all by itself equal to something. And so what we are going to do is split this up into two equations. Now in this particular case it doesn't really turn into two, because what we do is we need to let x minus 3 equal a positive over here, and x minus 3 has to equal a negative. Well, with 0 there's no positive, there's no negative, so it ends up being the exact same equation. So we can basically ignore one of them only because it is 0, and then add 3 to both sides and we get x equals 3. Quickly checking, 3 minus 3 is 0. Absolute value of 0 is 0. Continuing, example number 14. The absolute value of negative 4x is equal to 7. Now what goes on here is we've got the absolute value, so that means we can let negative 4x equal positive 7, or we can let negative 4x equal negative 7, and then just solve each one of these. So x might equal negative 7/4, or x might equal a positive 7/4. And quickly checking, negative 4 times negative 7/4 is 7. Absolute value of 7 is 7. 7/4. Negative 4 times 7/4 is negative 7. Absolute value of negative 7 is 7. And so it all works. And realize you do want to get into the habit of checking these, because oftentimes we get what are called extraneous solutions, which means solutions where we've done everything right with algebra, but it still comes up with the wrong answer. So you do need to always go back and check. Number 15. The absolute value of x plus 3 plus 1/4 is equal to 1. Well, we have this absolute value all by itself, so that means we can immediately put it into two separate equations. So we get x over 3 plus 1/4 equals 1, or x over 3 plus 1/4 equals -1. And just like when we had fractions, we're going to multiply through everything by 12. So we get 4x plus 3 equals 12, and 4x plus 3 equals -12. Solving, subtract 3 and divide by 4. Likewise, subtract 3 and divide by 4. And a quick check will say, yes, we are done.